Hello viewers, I am Dr. G. Littleflower from Stella College, feeling so happy to invite you all for another interesting talk on helium neon laser. Before going into the topic, let me say some interesting facts about helium and neon. Helium is the second element in the periodic table, second lightest element and second most abundant element in the universe. It has 2 electrons and 2 protons and 2 neutrons. It can also be represented like this: helium nucleus at the center and the 2 electrons revolving around the nucleus. Next is neon. Neon has 10 electrons and 10 protons plus 10 neutrons, making the mass number to be 20. So the nucleus, without marking the protons and neutrons, it is just represented as neon. 2 electrons in the first shell and 8 electrons in the outer shell. This is the structure of neon. Helium, if we want to say some more facts about helium, it is highly non-flammable, so it is easily can be used in balloons and in airships. And then near absolute temperature, it expresses superfluidity, which is a special phenomena. Means without any friction, it could just climb on the walls of the container in which it is kept. It's very striking phenomena. And then helium is very light, so it is used to pressurize rocket fuel tanks. Also, it is used to cool the superconducting magnets in the spaceships and the research apparatus and all. And neon we have seen every day in our life. During night time, if you go for shopping and all, we can see very neon signs and neon bulbs in various colors. So thus these 2 elements, helium and neon, are very fascinating elements which are highly used in technological and scientific fields. So using helium and neon, how a laser can be built, let me explain now. So this is a laser tube. You can see a sealed cylindrical tube. Inside, this helium neon gas mixture will be kept, and this part of this tube is called resonator, optical resonator, which contains 2 mirrors to the left and to the right. The left mirror is highly reflector, and the second mirror at the right side, it is called output coupler. It's partially reflecting and partially it is plain glass only. And we have 2 electrodes, anode and cathode. Let us see now how to construct helium neon laser. Yes, this is the tube containing the helium neon mixture. This is what called laser tube. The helium will be 10 helium neon ratio will be 10:1, and the pressure of helium will be at 1 millimeter of mercury, and the pressure of neon inside the tube will be 0.1 millimeter of mercury. And we have the electrodes between which we apply very high voltages in the range of 1000 to 2000 volts. So little more the dimensions of this laser tube. It has the diameter 1.5 centimeter. The length will be 80 centimeter. It uses the pumping method as electric discharge method, whereas in the ruby laser, it is excitation is done by xenon lamp, whereas here electrical discharge method is used. And yes, the output power will be 0.5 to 50 milliwatt, and wavelength, this laser source will give out a wavelength of 632.8 nanometer. Now optical cavity, I already told, it has 2 mirrors. One is fully reflecting, one is partially reflecting. Now when the photons are emitted, those photons will be getting reflected between these two mirrors multiple times, and it becomes amplified at a particular state that will be able to come through the plane part of this second mirror. The power supply used is around 1000 to 2000 volts at a frequency of few tens of megahertz. So when you apply the electric field between the anode and the cathode, this applied voltage will create discharge inside the tube, that is in the gas. It will ionize the gas. Some electrical discharge will be taking place. So we need a power supply which is to be applied between anode and cathode. The moment you apply and switch it on, that applied voltage creates electrical discharge in the gas mixture. Let us now see how this helium neon laser is working. So let me explain. I briefly tell before. So this is the tube. When you apply the electrical voltage between the electrodes, it creates the electrical discharge. So there will be a collision between the helium atoms and the electrons created due to this ionization. Due to that, the helium atoms will be excited to higher energy levels. When they return to the ground state, they will transfer their energy to the neon atoms. And then neon atoms getting excited to higher energy levels. Okay, so this is what I have explained here. First, we need to excite the helium atoms. This is done by the high voltage applied between the electrodes. And then when this excited helium atoms, after their lifetime gets over, when they come back to the ground state, they excite the neon atoms. Okay, so the neon atoms getting transferred to the higher energy levels. Now what happens in the excited states? The neon atoms cannot stay for longer time. They give up their energy as photons and they come to the lower energy level. These released photons will be undergoing multiple reflections in the optical cavity, and laser beam is produced. So the laser output will be a red light having a wavelength 632.8 nanometer. Even other wavelengths also can be obtained due to different transition, like you can have a green light at 543 nanometer. If you want infrared laser, then at around 1150 nanometer, they are possible with the different transitions. So this slide tells that first we need to apply the voltage between the electrodes. That electrical discharge releases electrons, high energetic electrons. These electrons and the helium atoms. Why first helium atoms? Why not neon atoms getting excited? So when we compare helium and neon, helium is the lightest one. So the helium atoms get collided with the electrons released by the electrical discharge and get excited to the higher energy levels. And when they return to the ground level once again, it shares its energy with the neon atoms. Now neon atoms are getting excited to the higher energy level, and when they jump back to the metastable states, and then they release excess energy as photons. These photons undergo multiple reflections in the optical activity and gets amplified and comes out as a laser light at 3 wavelengths, 632.8 nanometer, 543 nanometer and 1150 nanometer. So you can see different colors we can create. We can obtain laser light from the helium neon laser. Now the energy level diagram is shown here. Helium has 3 levels, E1, E2 and E3. And neon has 1, 2, 3, 4, 5 energy levels. Okay. So the first part of the working is that you are applying the heavy voltage, the high voltage between 1000 to 2000 volts between the electrodes. Now what happens? That applied voltage creates electrical discharge in the gas mixture and releases some electrons. Now, the helium atoms collide with the electrons and they get excited to the level 2 and the level 3. See, this is done due to collision by accelerated electrons, which are created by the electrical discharge inside the tube. Now, these excited atoms, so number of helium atoms in the ground level, once due to electrical discharge, they collide with the high energetic electrons getting excited to the higher energy level. We know the levels E2 and E3 are metastable states. There, the helium atoms cannot stay for a longer time. So what they do? They come back, they jump back to the ground state from E2 and E3, releasing some photons, some energy, the excess energy. Because of that excess energy, they went to the higher energy levels and now they return back, they give out their excess energy. Now this photon of energy will be shared with the neon atoms. So neon atoms from the ground state E1 dash, they jump to straight to E4 dash and E5 dash. E4 dash and E5 dash are metastable states. Because we have two different elements here, we are representing the energy levels as E1, E2, E3. Here E1 dash, E2 dash, like that we represent. So when helium atoms come to the ground state, they share the energy with the neon atoms and the neon atoms getting excited by the helium atoms collisions and they jump to E4 dash and E5 dash. You know, these two states are metastable states. That means they don't have, means they can, from the higher energy level, if that atom jump to this metastable state, they can stay a little longer than the expected time, 3 into 10 power minus 8 seconds. 3 into, or you can say 10 power minus 8 seconds. So little longer than 10 power minus 8 seconds. So when they are excited to these states E4 dash and E5 dash, they stay there for excess time and then when they return back to the lower energy levels like E3 dash, now what they do? They release the photons. Now these photons are undergoing multiple reflections in the optical cavity between the mirrors, left and right mirrors. Multiple times they get reflected. Every time they hit the mirror, they get reflected. They now getting accelerated. Then like that, slowly they gain, they get amplified, and then it comes out as a burst of photons called laser light. You can see all the photons will be having same energy, same wavelength, same frequency. So as a burst, it will be coming out of the output mirror, the second mirror. They come out. That is what called laser light. Okay, already we have seen that its wavelength is 632.9 nanometer. Now after releasing that, the neon atoms slowly jump back to the E2 state by spontaneous emission. Maybe little energy is released, but from here it will come to the ground state and completely losing the excess energy that is kept down in the higher energy levels. That way you can see a simple dance of helium and neon atoms from the ground level to the excited energy levels. Through the stimulated emission process, we are getting laser light. This is the energy level diagram. So here 4 steps are involved. First of all, the helium atoms to be excited. When they return to the ground state, they should excite the neon atoms to go to the higher energy level. Right? So first is helium atoms and going to the higher energy level and coming back, releasing this photon. That is first step. And these photons share their energy with the neon atoms. Neon atoms getting excited to the metastable state. And now third step is that they are creating the stimulated emission. And then fourth step is that they return back to the ground state. Now, what is the role of helium in helium-neon laser? Helium atoms are, already I just explained, helium atoms are very lighter compared to the neon atoms. So, when the electrical discharge takes place between the electrodes in that tube, laser tube, the helium atoms first getting excited when they return to the ground state, they make the neon atoms to go to the higher. They make the neon atoms to go to the higher energy level. You can see here, when the excited helium atoms come back to the ground state, they make the neon atoms to go to the higher energy level. Okay, then because helium atoms are very lighter, they get excited first, and then helium atoms in the excited energy levels E2 and E3 collide with the neon atoms in the ground level. Neon atoms are excited to energy levels E5, 4 and E6, and helium atoms come back to the ground state. The neon atoms are much heavier and could not be pumped efficiently without the help of the helium atoms. That is why we take in the laser tube a mixture of helium and neon, and that to helium in good amount, 10:1 ratio. Neon atoms are actually the active element there. Their ratio is 1, whereas helium ratio is 10. The role of helium atom is to excite neon atoms and cause the population inversion. So in the earlier talk, I have told you what is population inversion. That is the atoms, number of atoms in the higher energy levels becoming more than the number of atoms in the ground level. Then you can say population inversion has taken place. So here population inversion of neon atom is taking place because of the presence of helium atoms. Now let us see some of the applications of this helium neon laser. Helium neon laser, the output will be a coherent beam. What do you mean by coherent? They all will travel in the same direction. The photons will be in same phase. They will have same energy and same wavelength, same frequency. Together it comes out. So night time when we stand at the roadsides, you can see the light from the headlights of car or buses, they go like this. Whereas laser light, if you put it on, you can see like a spot, just spot, without getting diverged, they will be traveling forward. So you call it as a coherent beam, right? So helium neon lasers are commonly used for precision measurements. Anything if you want to measure very, very precisely, then it is better to go for helium neon laser. Okay, in engineering and scientific experiments, mostly we use this helium neon lasers only. The coherent, monochromatic, single color, not multi-mixing of colors. Mixing of elements are there, but the output will be single color, single wavelength and coherent. Because of that, they are mostly used in technological and scientific experiments. Then while nowadays holographic photography has become very popular, cinemas taken with the holographic and wearing the spectacles and watching the movie is simply amazing. So here helium neon laser only is used to illuminate the object and to construct and the reconstruction of the image of the object. For that we use this helium neon laser only. Same way everywhere nowadays when we go to shop, barcode scanning is there. They just take the product and show it before the scanner. Immediately one beep sound comes and reads out what is the cost of the item which we have bought. So there also we use only helium neon laser. Then interferometry. This is another technique which is used in multiple ways in physics, and especially for precision measurements of distances and surface irregularities. We use this interferometry. Even for determining the refractive index and all, we use interferometry. There we use this helium neon laser source as a source of light. Okay, and medical applications, helium neon laser is most preferable for eye surgeries and the skin treatment, because the rays out of that bulb goes as a straight line, very thin beam of light. Okay, you can focus it on smaller area and can do the medical treatment there using this helium neon laser. Not only that, even in optical experiments, like mostly in laboratory level, this is helium neon laser is very useful to do many experiments, because it is very simple to design and simple to handle and very safe also. So most of the laboratories will have helium neon lasers. And in spectroscopy, whenever we go for research and study the material characterization and all, we go for spectroscopic studies in Raman and other forms of spectroscopic studies. Here, once again, we use this helium neon lasers. It's purely because of its high coherence nature. Okay, so first we use this helium neon laser and excite the material, and we study how this the particles of the material is interacting with the light. That way the characterization of that material can be done. So here also we use helium neon laser. And then for laser printing, if you take Xerox and laser print, you can see a laser print will be very neat and very clear, elegant also. There also we use helium neon lasers to produce a static image of the words that has to be printed on a drum, which will absorb the toner particles and make the system ready for the final print. So laser printing is done with the help of helium neon laser. And in communication systems nowadays, after the entry of this computers, everything, optical fibers are helping us to communicate between the computers and okay, here we use this helium neon lasers only for high speed transmission of data over short distances. Okay, optical fiber communication mostly use helium neon lasers. Then what are the advantages of helium neon laser? As I already told, the quality of the helium, the beam, the laser output will be very high, very narrow, stable. That ruby laser, whenever you put on, you get laser light from the ruby laser. A pulse only will be coming out. Next pulse, if you want, you have to again put it on, like that. Pulses of laser light will come. Whereas helium neon laser, once you put on, continuous output of light. How I am getting light from this source, continuous flow of light will be coming out. And it will have a good phase, everything already I told. Good wave, same wavelength, same frequency, and all the photons will be in same phase. So it has very good high quality and cost effective, cheaper, because helium is the second most abundant element, and neon also, both of them are highly stable. So designing helium laser is very cost effective, very inexpensive. And then the light coming out of helium neon laser will be very stable wavelength, single wavelength. Okay, single wavelength. And for a longer distance also, if you just focus, see this bulbs and all illuminating the entire room, because the light is not a coherent beam. It is just diverging and illuminating the space. Whereas from helium neon lamp, if I put it on, the entire room cannot be illuminated. It just from the light source, it just go like a spot only, it will be seen. So long coherence length suitable for high precision optical measurements and holography, which I already mentioned. Now, what are the disadvantages of helium neon laser? Disadvantages means the power output compared to ruby laser also, power output will be little less compared to modern. And if you compare with the semiconductor laser, its output power will be very less. So you can't use helium neon laser for high energy tasks. Yeah. Then that apparatus will be little bulky. I showed in my third or fourth slide. It's so long and so bulky. So the gas tube and the necessary power supply make helium neon lasers larger and more cumbersome than compact semiconductor lasers. This combination of simplicity in designing, stable operation, and versatile application makes helium neon laser an essential tool in many fields. So with this, we will make a little comparison between ruby laser and helium neon laser. What is the difference? And when we study the difference, we will come to know which is better, right? So the ruby laser, if we take, it produces pulsed laser beam, the output will be only in pulses. And helium neon laser, it produces a continuous laser beam. Okay, and then ruby laser is a 3-level laser. So already in the earlier talk I have explained about the working of the ruby laser. 3-level, that chromium atoms will be excited to higher energy levels, first step, and they transfer to the metastable states, and then from metastable states to ground state, when they jump, it gives out the laser light. So it is a 3-level only, from ground state to excited state, first step, from higher energy level to metastable state, second step, and when they jump to the ground state, it is giving out the laser light, 3-level. Whereas helium neon laser is a 4-level laser system. First, helium should go from ground state to the higher energy level and jump to the ground state, that is first step. Then it makes the neon atoms, it push the neon atoms or excite the neon atoms to the higher energy level and go to the metastable state. That is the second process. From the metastable state, when they come to a higher energy level to metastable transition is second level. From metastable to the lower energy levels, third step, and from lower energy level to the ground state and get de-excited. Thus, helium neon laser is a 4-level laser system. And then in ruby laser, we use optical pumping. Pumping means some energy we are supplying so that the atoms from the ground level can go and occupy the higher energy level. So here we use optical pumping. Optical pumping, here we use xenon flash lamp. Okay, and xenon flash lamp, when you put on, a high amount of heat energy will be released. So to keep them cool, again we have to supply some cooling arrangement and all. So optical pumping method, whereas in helium neon laser system, we use only electrical discharge. We apply the voltage between the electrodes, electrical discharge takes place releasing the electrons, then collision between the helium atoms and the electrons take place, and the process goes. So ruby laser has optical pumping. Here the pumping method is electrical discharge pumping method. The fourth difference is the active medium is in solid state. Ruby laser, the active medium containing the impurities chromium atoms will be in the solid state, whereas helium neon laser is a gaseous state laser. You have helium gas and neon gas in the ratio of 10:1. And then whenever you use xenon lamp for optical pumping, lot of heat energy will be generated, so you have to cool it. So in ruby laser you need a cooling arrangement, whereas in helium neon laser there is no need of any cooling arrangement. Now from ruby laser we get a laser light of 694.3 nanometer. 694.3 nanometer, whereas helium neon laser produces a laser light of 632.8 nanometer. Okay, wavelength wise it a little less, but energy of the laser light that is coming out of helium neon laser is more than the ruby laser. Okay, because we know energy equal to h nu, or you can say hc lambda. When lambda is less, its energy will be more. That's why it finds applications in the medical field and all. I hope you would have enjoyed how the helium neon laser is constructed, how it is working, how we can get different laser light with the different wavelengths by making use of the different transistors in helium neon laser. You would have understood. So thank you all for listening to this talk. I hope you would have enjoyed. We will meet once again with another interesting topic. Thank you.